Hello students, in this lecture we will discuss about the atomic spectra of hydrogen atom. As we all know that we have already studied that energy of electron in case of hydrogen atom, it is given by this expression where all these quantities, mass of electron, charge on electron, absolute permittivity, Planck's constant, all these quantities are constants. So after putting the values of all these quantities, we will obtain this expression in electron volts. So from this expression it is clear that the energy of electron in hydrogen atom, it purely depends upon principal quantum number n only, and n carries values from 1, 2, 3 and so on. Now the next question arises that how the spectrum of hydrogen atom arise. So we get the spectrum of hydrogen atom when the electron in any higher state of hydrogen atom jumps to the lower state. Now next question is that is there a transition possible from every higher state to every lower state? No. Only few transitions are possible. Only those transitions are possible from higher state to lower state which follow certain selection rules. Now the selection rule for allowed transitions in the case of hydrogen atom is that the change in the value of orbital quantum number L, it must be equal to either +1 or -1. So only those transitions are allowed from higher state to lower state for which the change in the value of L, that is delta L, it is either +1 or -1. Along with this, there is no restriction on the value of n. Here you can see in this figure 7.27 we have the energy level diagram of hydrogen. So this is 1s energy level corresponding to principal quantum number 1. Corresponding to principal quantum number 2 we have energy levels 2s, 2p. Corresponding to principal quantum number 3, we have energy levels 3s, 3p, 3d, and corresponding to 4, we have 4s, 4p, 4d, 4f, and corresponding to n5, we have again all these 4 energy levels up to infinity. So here you can see that the spectrum of hydrogen atom consists of 4 series, and those 4 series are sharp series, principal series, diffuse series and fundamental series. And what is the meaning of these series? Actually, as you can see, S stands for sharp series. If the electron is in any higher state and that higher state is any S state, so for delta L is equal to ±1, from higher S state the electron can only jump to p state, because we know that for S state L is equal to 0. For electrons in p state L is equal to 1. For electrons in d state L is equal to 2. And for electrons in f state L is equal to 3. So if the electron it is in higher state and that higher state is S state, then according to the selection rule delta L is equal to ±1, that electron it can jump only to the lower p state. Here you can see the electron which is in 3s state, it can only jump to 2p state, because for that change in delta L is 1 and there is no restriction over the value of n. The change in n is here 3 to 2. And as you can see, there is transition from 4s to 2p. The change in the value of L, delta L is +1 or -1, and the change in value of n, principal quantum number, that is 2. And we know that there is no restriction on the change of principal quantum number. So same transition will be there if the electron is in higher state 5s. Now that electron, it can show transition from 5s to 2p and it will come under sharp series. So all the transitions from higher S state to lower p state, it is known as sharp series, and for this n varies from 3, 4, 5 and so on. Then next comes principal series. What are the transitions which are included in this principal series of spectrum? So in case of principal series, the electron, it will be present in any higher p state. And again, if p state is higher state, so from that p state, electron can only jump into s state. Because we know that emission spectrum arises only when electron jumps from higher states to lower states. So in this case of principal series, the electron, it is in higher state, that is any p state. Now, according to this selection rule, delta L is equal to plus minus 1. From this higher p state, electron can only jump into s state, lower s state. Only then delta L will be equal to plus minus 1. So here you can see that this is higher p state. If the electron is present in this 2p state, then it can jump to 1s state. It will give rise to principal series. Similarly, if the electron is present in higher 3p state, it can jump to 1s. According to this selection rule, delta L is equal to plus minus 1. And similarly, if the electron is present in 4p, from 4p it will jump into 1s. So, in case of principal series, all those transitions will be included in the principal series in which the electron is present in higher p state and the transition is from higher p state to lower s state, that is 1s state. So, all the transitions, they are from np to 1s. And in case of sharp series, all the transitions, they were from ns to 2p, where n varies from 3, 4, 5 and so on. And in case of principal series, the transitions are from np to 1s, where n varies from 2, 3, 4, 5, 6 and so on. Next comes diffuse series. Diffuse series, it starts from D. It means it will include all those transitions in which initially the electron is present in higher D state. Now it will move to lower P state. Why the electron, it can only show transition from D to P? Because only then this delta L value will be plus minus 1. So, suppose the electron is present in higher state, 3D state. It will jump to lower state, that is 2p. If the electron is in 4D, again it will jump into 2p. From 5D it will jump to 2p. So all these transitions will be the part of this diffuse series. So upon generalization, this will be a transition from ND to 2p, where n varies from 3, 4, 5 and so on. Next comes fundamental series. Fundamental series begins with F. So this fundamental series, it will include all those transitions in which initially the electron is present in higher F state. And for this selection rule, delta L is equal to plus minus 1, it will be obeyed only if the transitions, they will be from higher F state to lower D state. And lowest D state is 3D. So here the transitions will occur from NF to 3D, and value of this N, it will be 4, 5, 6 and so on. Here you can see the theory which I have explained to you earlier. Now here in this circle you can see the detailed structure of the transitions from the level n is equal to 3 to level n is equal to 2. As we know that in case of spin orbit coupling, there is splitting of energy levels. So we know that corresponding to S state, the value of L is 0. So what will be the value of J? It will be L plus S, L minus S, it will be equal to plus half only. So this is the value of total angular momentum, that is J, which is equal to L plus S, 0 plus half, so it will be half. So there is no splitting of S state, but we know that for P state, this is 3P half, this is 3P 3 by 2. We know that for P state, L is equal to 1 and S is equal to half. So for p state, the values of j will be L minus s to L plus s, means 1 minus half to 1 plus half. 1 minus half will be half and 1 plus half will be 3 by 2. So this p state, it will be splitted into two energy levels after LS coupling or after spin orbit interaction. Same is the case of d state. So here you can see the transitions from n equal to 3 to n equal to 2, it actually consists of 7 components. How? Because here the selection rule delta L is equal to plus minus 1, along with this selection rule, another selection rule is followed here, that is change in the value of j. So after considering the spin orbit coupling, what will be the selection rules? There will be two selection rules, that the change in the value of L, it must be plus minus 1. Along with this, the change in the value of j, it must be either 0 or plus 1 or minus 1. Here you can see transition from d3 by 2 to p1 by 2. Here the change in the value of j, delta j, it is plus 1. From 5 by 2, transition from 5 by 2 to 3 by 2 is possible because change in delta j is plus 1. But transition from 5 by 2 to p1 by 2 is not possible because delta j is plus 2 here, and which is not allowed by the selection rule. Similarly, from p3 by 2, only transition is possible to s1 by 2, from p1 by 2 to s1 by 2, and from here the transition is possible from S1 by 2 to P1 by 2 and S1 by 2 to P3 by 2. So there are total of 7 components in the spectrum of hydrogen atom in case of H alpha line when we are considering spin orbit coupling.